Nice of you to come to my talk about JPA and especially what makes JPA so complex. Before I really start, I would like to know to whom I'm talking, since Spring 1 is for the first time combined or part of VM Explorer. I don't know if I'm up for a surprise. So who here classifies themselves as a developer? That's basically everybody. Who is a Java developer? Still most, obviously. Okay, now, who uses Spring Data? Good. Who uses JPA or Spring Data JPA? Still almost all. And now this question I'm most curious about, who uses Spring Data JDBC? Only a few. We'll see if we can change that. Oh, one more question, especially to those that use JPA or Spring Data JPA. Who does like JPA? Okay. So, nobody is going to throw stuff at me if I complain a little. You probably have seen that in another talk already. Legal talks to you silently. So having said that, we don't make, or I don't make any legal guarantees for upcoming features or similar. I also don't make guarantees about that what I tell you about JPA is completely right, completely correct. I have a couple of examples with me, and there are probably some corner cases that still behave differently than I think. When I came up with these examples for this talk, I actually learned again something about JPA, and I'm using JPA, or which might be considered its predecessor, Hibernate, for now over 10 years, I think. So it's a complex beast, but that's why we are here, right? And what's the best way to learn stuff? It's answering questions, because only if you answer questions honestly, without looking stuff up, you can see if you really understand what you think you have learned. So we start with a couple of questions. You probably, or hopefully, everybody is familiar with the entity manager, and the question is a really simple one. If you call entity manager.persist with an entity, does that entity get written to the database? And I'm not talking about like some weird shit like constraints failing or something. Just a plain entity that you persist. Does it get written to the database? Who says yes? 1, 2. Go ahead. There's no blame. We have no cameras here. Nothing gets told to bosses or anyone. Who says no? A few hands. Who says it depends? Okay, yeah, so you take the easy escape. Why does it depend? What does it depend on? Not you are, you know that. Anybody else? Pardon?
Flushing.
Sorry again.
Flushing.
Flushing? Yes, but that's not what I'm out for. Okay, so everybody said it depends, but nobody seems to understand what it depends on. So let's see. For this talk, I have created a simple test. Just run it real quick. It uses test containers, as you've seen in the keynote, to start up a database, runs all the tests are green. So everything that I'm going to show you, as far as asserts go, all asserts pass. And I have in this test a little infrastructure. We have the entity manager, We also have for later cases or tests a transaction template that allows us to explicitly start and end transactions. And we have name parameter JDBC operations, a fancy version of the JDBC template, which allows us to look directly into the database without going through JPA. Because the problem with JPA is it does stuff, and sometimes not the obvious. The before just cleans the database, so nothing interesting here. Oh. Oh, sorry. That needs fixing. Displays. Sorry. Why do I have only one display here? That is strange. Any? Pardon? To what? No, it works. Okay. Oh, it doesn't? Oh, I don't understand it. Sorry. Okay. Quick again. Here's the infrastructure. I talked about the simple setup, which just clears the database. And the first two tests. One just creates a minion. It calls persists because we're talking about persists. And then it asserts that actually no minion is written to the database. So that does work. And if I do the same thing, but with a person, it asserts that actually a person is written to the database. So what the heck is going on? Any ideas? Okay. Person has relationships is a good idea, but not totally correct. So this is the person. This is the minion. Did anyone spot the difference? The ID. Somebody said the ID. And that is exactly the difference. One entity takes its ID from an outer increment column in the database. And persist is guaranteed to give you back an entity with the ID value filled. So in order to get that ID, it has to perform an insert into that table. But JPA or JPA implementations actually don't want to do that if they can avoid that. So in the other case, where the ID is coming from a sequence, it just does a select on the sequence and puts that in the entity, and no insert is actually happening. And this is totally fine as long as you only use JPA. It will make sure everything works and looks nice. But as soon as you use something else to directly interact with the database, you are getting this kind of problem. So, can I start this presentation? Okay. So that was the question. The answer is, what persist actually does, it puts the entity in the persistence context, also known as first level cache. And the flush thing is exactly, if you want to make sure that it actually is written to the database without committing, you can call flush. The alternative is, if you end the transaction with a commit, a flush gets triggered. And if you don't do that, it actually depends on the ID, or, which also was mentioned here, on references. Like, if it has references that also get persisted, it might have to have a reference back, so it's complicated. So let's look at the other way around. Loading stuff with entity manager.load. Does that load anything from the database? Who's for yes? Who's for no? And who is for depends? And who wants to explain why it depends and on what it does depend?
Whether it's greedy or not.
Whether it's greedy or not. So you're referring to lazy loading. Yeah, that is relevant. Caching is a good point. Anything else? Yeah, so the answer was if the query constraints actually match what is in the database. But we are talking find. We are not doing a query, not a select something, but just find by ID. So, and of course, still, if there's nothing with that ID in the database, nothing will get loaded. That's true, but that's not the one I'm looking at. So let's look at the next test. And I need to switch displays again, I guess. Why? I honestly don't understand how this works. So the next one. Still same test class. And again, we have two cases. First, just to be sure, I'd use the JDBC template to create an entity of the minion type, because we have seen if the minion gets written or not depends on too many things. And then I try to find it in the database and check that it actually loaded something with the correct name. And in the second case, I use the setup method, which I haven't shown you yet, which creates a minion using JPA with the name Jens. But then it uses the JDBC template to update that name. So maybe some batch process or something in the application changed some data around. And now I load that entity, and as it turns out, the name in that entity is still Jens, although I just asked it to load it for me from the database. So what is happening here is, again, the same first level cache / persistence context from the previous example. It looks first in that cache, and if it finds an entity there, it just returns it and doesn't look at the database at all. And it isn't as nice, but it avoids breaking myself fingers. So find looks at the persistence context first. Next question. There was already the mentioning of the where clause, the conditions. So if I do a query, it has to hit the database, right? With a query, does it load stuff from the database? Who says yes? Who says no? And who chickens out and says it depends? Or is it complicated? So what is so complicated about it? I want to load an entity, can't be complicated, right? Again, next test case. I again create a minion with my name, Jens. I again update it to the name Mark. And then try to load it using the old value of the name, Jens. And that obviously fails. I just changed the name, so there's no minion named Jens anymore in the database, right? But if you look at this case, I do exactly the same, but now I'm querying for Mark, and I get an entity back. Yeah. But if I look into that entity, it says actually Jens. What the heck is going on? And it's the same thing as before. It does execute the query against the database now to check if it gets any entity data back. But then the first thing it does is it takes the ID and looks in the first level cache, and if that entity is already there, it returns the version from the cache, not the one that just got loaded. And this, at the latest, is the place where developers get really frustrated because they lose their belief in that they understand what they are doing. And that is actually quite correct in many cases, unfortunately. So we bitched about the first level cache enough. How about this case? That's actually something that in my experience, most developers didn't even think about, which is kind of scary. So you have an entity, A, which has a list of Bs. And it also has a version attribute, so you're doing optimistic locking. And now you change something in the list of Bs. You add or remove stuff, you change entities in there. Does that affect the optimistic locking version in A? This is important because A might be in order and B the line items, and you might do some verification, like is this order okay? Can I continue processing that? And while that process is working and testing that and maybe at the end updating the status, you want to make sure nobody changes the line items in the meantime, right? So how does that work? Is the answer yes? One says yes, two. No? Yeah, a few more. And it depends. And nobody dares to say anything because he knows I will ask why, what is going on? And again, a test. This time we're dealing with Smurfs, and the reason is actually what was mentioned before, relations, because if you add relations to an entity, the part about creating an insert or not changes, and so I created that example first, I think with minions, and all the other tests broke. So I created a new entity, Smurf. Smurfs have clothing, and Jokey here has shoes, pants, and jacket, so he's reasonably dressed. And we save the version in order to be able to compare it later. And then Jokey removes all his clothing. And luckily, if you imagine there was a check if he's allowed to enter this conference, that version changed. So all is good, right? We check if every Smurf is properly dressed, and if somebody comes in without clothes, the transaction will fail. If you make it a little different, again, Smurf, which should be called Jokey because Bob is a minion. But this time, Jokey just changes his clothes to be transparent. And now, the version does not change. And just to be sure, because we are taking the entity that we loaded and manipulated, maybe we need to reload it or something, we actually do that. We find the Smurf again in a new transaction, and yeah, still the same version. So this stuff, the other stuff was kind of, Gavin King would say, like, just use it correctly, then it will work. This stuff I just consider broken. There's just really no way somebody can explain to me why this should be the correct behavior. You can tweak that behavior a little, at least in Hibernate. I think that's not a standard JPA annotation, to, I think, never update the original version, which makes sense in some cases. But this is broken. This breaks business logic. Hello? So, updates to the collection do trigger a version update. Changes to elements in the collection don't. Next question. Can you use Java records in JPA for entities? Yes? You're sure? Because I think you can't. You probably can use it for values, but not for entities. Again, I don't give any guarantees if somebody tells me that they managed to do that, but I don't think it's actually possible because JPA is based on dirty tracking, which means it keeps a reference to your entity, sees when you change something and knows, okay, I have to save that. And since the records are immutable, it doesn't have a way to do that. Which brings us to the second part of the talk. Why the heck is this so complicated? I mean, bitching about it is like, it helps. Well, if you have mental problems, talking about it does help. I'm not making fun of that, that's actually real serious. But why did they do that? Are they stupid? And the answer to that is definitely no. The people that created Hibernate, that created JPA, are smart people. And they spend a lot of time with it. And me bitching about it is just, I've been in the Java world, in the JVM world, in a time where we didn't have Hibernate. And that wasn't better. And then I've been in the world where we had Hibernate and also like 20 other object relational mappers, and that wasn't nice either. And the reason why Hibernate won and then JPA got basically created out of a Hibernate and a couple other object relational mappers, that's a good thing. That was a step forward. But now it's, again, I don't know, 10 years later or something, and it's time to realize that we have a problem. And I think this XKCD, which you probably know, and which was originally referring to just software in general, I think that is quite fitting for JPA. And in JPA, the dirty tracking, that's actually the one that causes the problems. Again, dirty tracking, I just talked briefly about it. The entity manager has the persistence context and uses that to keep track of your entities. That is why for each entity there can be only a single instance. You might have experienced that when you load something and you load something through a different way and you try to add that together and suddenly you get like duplicate entity exceptions or something like that. That is because if you do dirty tracking and you have two entities that, or two instances that really refer to the same entity, you now have two different states. And which one should you write to the database? Should you try to mix them up? That's not going to work. So you can have always only one instance. But not of that entity only, but also of all the references to that. And with JPA, you typically have a network of entities, like there are object references everywhere, and you basically can start with a single entity and navigate your way around. Depending how exactly you build your application, you might end up loading your whole database. The solution for them was caching, the persistence context, first level cache. But caching is one of the well-known two big problems of software engineering, all right? And now just because we want to store stuff in the database, we now have to deal with caching. Like people working on Hibernate and JPA, and people like that bet their lifeblood on that, try to tell you that caching is a good thing because it increases performance. And yes, that might be true in some cases, but that is no reason to mix persistence and caching. The right way to do this is to have persistence and then put caching on top of it. And if you don't want caching, you should be able to remove it, or not to insert it in the first place. And the other problem is there are no clear boundaries. That's the one I mentioned, that everything is referencing everything, and you can navigate your database. Lazy loading everywhere, which also is like, oh, you're calling a getter and suddenly a SQL statement gets executed. Like a getter should take like, what, microseconds or something? And now you're talking to a database and that's not going to happen in a microsecond. So that's not nice. So what you really need are boundaries, like things that encapsulates entities or groups of entities in a meaningful way. And you can do that with JPA, with lazy loading and cascading, but you blast your domain model with cascade annotations, and it's really hard to see what is really going on. So the question, obviously, well, are we just stuck with some solution that we don't really like, or what is the alternative? And if you know what I do for a living, you know the alternative. I think it's Spring Data JDBC. Because Spring Data JDBC starts with a different premise, a much simpler one. Apart from what I list here, the premise was it has to be done by me and maintained by me. So the Spring Data team is six people, and we have like a dozen modules. So there's not that much work that can go into each module. We are still making progress, sure, but it's not like Hibernate, which has like, I don't know, 10 people, it seems, and that for, I don't know, 10 years, 15 years or something. So entities in Spring Data JDBC are never proxies. They're plain, simple Java objects. They're also not cached in any way. We don't keep a reference to an entity that we hand out to you. And if you ask Spring Data JDBC to load an entity, it will load an entity. And if you tell it to save an entity, it will save an entity. What a surprise. And if you do that 10 times in a row with the same entity, it will save the same entity 10 times in the database. And if you don't like that, well, then don't do that. And also, it has aggregates. It really, if I don't watch what I'm saying, I keep saying things like you save an entity, but you don't do that, you save an aggregate. And what you give to Spring Data JDBC, to the repository, is the aggregate root, which then references 0 or n entities, and all those belong to the same aggregate, which means they get persisted together and they get loaded together. And there's a very strict boundary to everything else that doesn't belong into the aggregate, because it doesn't get referenced by a Java reference. It just gets referenced by ID, or with a little wrapper type aggregate reference, which is just a marker saying, okay, this long is not a number that you can multiply and add to something else. It's an ID to some kind of entity. And that makes life much, much simpler. I'm not lying, it makes life simpler for me implementing this stuff, but it makes also life easier for the user who actually understands what's going on. And especially if you have to integrate with other stuff that access your database directly, and although that is frowned upon, I'm sure that is happening in many, if not in most applications, still in 2023. So my ask is, if you haven't already, give it a try. To get started, there's the project page, which links to the GitHub repository, the documentation, and everything. And what I consider quite important is the article, the second link, which explains this aggregate reference stuff in a little more detail. Everybody done with taking photos? But then, of course, I guess there are many people that have to use JPA for one reason or the other, and I can totally relate that. If you have a big application written with JPA and 20 developers working on that, you are not going, hey, I've been at that conference, let's do everything with Spring Data JDBC tomorrow. That's not going to happen. But if that is the case for you, please make sure that you understand how the first level cache works and how it interacts with what is going on with JPA. And that's all what I have for you. If you want to get into contact with me, you can use Twitter for this conference. I'll go off Twitter after the conference again because Twitter just isn't healthy. Slides and source code for this talk are on the GitHub repository. And please take the survey. And I'm done. Do you have questions?